Hello! We're working with exponent operations now. So the next few videos are going to be multiplication, division, dealing with some special cases, etc. The first thing we're going to deal with is multiplication. Now, if you take a look at the board, I've written the algebraic way to represent multiplication. And that would be x to the a times x to the b equals x to the a plus b. Now I want to stress a couple of things here. The first thing I want to stress is that we're adding exponents only when the bases are exactly the same. That means that it's got to be x and x. If this was x and y, we couldn't do this. The second thing is it seems a little counterintuitive, is that, hey, we are adding for a multiplication problem. So first, let's just do the first example. I've got x to the third times x to the fourth. They both have exponents. That's when the adding exponent rule applies. So this is going to equal x to the seventh. Yes, we add these. Now, as far as why we add, it's really pretty straightforward and simple. Take a moment and let's write out x to the third. X to the third, if we wrote it out in expanded form, is x times x times x. X to the fourth, if we wrote it out in expanded form, is x times x times x times x. And these two things, when parentheses are next to each other, it also means multiply. Well, I think it's obvious that there are 7 x's that are written here, and x is multiplied times itself 7 times, so it would be x to the 7th. Alright, let's do a few more examples. X to the 9th times x to the 12th. I certainly don't want to write 9x's and 12x's. I'm just going to add the exponents. The bases are the same. So that would give me x to the 21st, because 9 plus 12 is 21. Here's one that students get tripped up on all the time. They see a 7 and a 7 and they want to multiply it. If they have numbers but they have exponents, you have to add the exponents. The answer for this is 7 to the 13th. Think about it. I'd have 4 7s written here and I'd have 9 7s written here. I'd have 13 7s. I wouldn't have any 49s. So you don't multiply them when they have exponents. You just add the exponent. Here's one where there is numbers and exponents, okay, together. So we've got 2x to the 4th times 3x to the 5th. These numbers don't have exponents. We multiply normally there. 2 times 3 is 6. The exponents, x to the 4th and x to the 5th, we add those and we get x to the 9th. So it's 6x to the 9th. The last one, negative 7 x to the 2nd, y to the 3rd, times 4xy to the 2nd. So the negative 7 times the 4, those are normal numbers. That is negative 28. I'm going to run out of space here, so I'm going to write beneath. I've got x's and I've got y's, so I'm going to add up the x's. I've got a 2 here, and if you don't see a number, what number is there? It is understood that there is a 1 for the exponent. So 2 plus 1 is 3. So it's going to be negative 28 x to the 3rd, and then y to the 3rd times y to the 2nd would be y to the 5th. I'm going to go ahead and rewrite that. Negative 28 x to the 3rd, y to the 5th underneath there. Anyway, that is the basic on exponents. When you're multiplying and there are exponents involved, you add the exponents, you multiply regular numbers. I know people want to say these 7s are regular numbers, but they have exponents. When they have exponents, you add the exponents, leave the base alone. Good luck.